What's up, people? Welcome back to another Swift 3 tutorial. Today we are gonna learn about polymorphism in Swift 3. So let's create a new playground, hit next, and create. We can delete the first line. So when a computer language has a hierarchy of types and subtypes, it must resolve the question of what such a hierarchy means for that relationship between that type of an object and the declared type of a reference to that typical object. Swift obeys the principles of polymorphism. In my personal view, polymorphism turns an object-based language into a full-fledged object-oriented language. So let's summarize Swift's polymorphism principle. So the polymorphism principle, one is substitution, and the second one is internal identity. Substitution is wherever a certain type is expected, that it is a subtype of that type, and the second one is internal identity, which is an object's type that is matter of its internal nature, regardless of how the object is referred to. So let's comment it down. So there are the two principles, which are substitution and internal identity. Now let's see what these principles mean in action. So imagine we have a dog class along with its subclass noisy dog, right? So let's write it down. We will say class dog, open curly brackets, close curly brackets, and we have a subclass which is called noisy dog. Parental dogs, open curly brackets, close curly brackets, and we want to initialize our dog and our noisy dog. So we say let D equals dog equals noisy dog perhaps. So this is a substitution rule that says that the last line right over here is legal. We can assign a noisy dog instance to a reference D that is typed as a dog. The internal identity rule for our second principle says that under the hood, D is now noisy dog. That's the internal identity. So you may be asking to yourself, how is the internal identity rule manifested, right? If a reference to a noisy dog is typed as dog, in what sense is that really a noisy dog, right? To illustrate, let's examine what happens when a subclass overrides an inherited method. Let me redefine dog and noisy dog to demonstrate. So let's comment this out so I can just retype it. So let's say we have a class dog, right? And then we need a function that we can see bark, right? Function bark, open curly brackets, close curly brackets, and we want to print out, and we say wolf, because the dog barks and it just pronounces as wolf. And then for our subclass, we got noisy dog, open curly brackets, close curly brackets. And then we want to override that I said earlier. Func bark and then we need a super bark. Super bark 2 times. And we say class dog func bark. Let me just, yeah, let's rewrite it. And then we want another function which we can say speak. And over here we say speak self. Oh, bark, not speak, bark. There you go. And then over here we can say our subclass noisy dog override and then our super. Okay, so what happens to say to a noisy dog to speak, right? So let's try it over here. Let dw equals noisy dog, and then we say dw speak. It says woof woof, right? That's a nice way. The speak method is declared in dog. The superclass is not in noisy dog. The speak method calls the bark method, and it does this by way of the keyword self, which we have self.bark. We are using the keyword self. So there is a bark method in dog and an override of the bark method in noisy dog. So you're just probably wondering which bark method will be called. So the word self is encountered within the dog classes. Implementation of speak. But what matters is not where the word self appears, but what it means. It means this instance, and the internal identity principle that we have tells us that this instance is a noisy dog. It is noisy dog's overriding of barked that is also called. So polymorphism applies to optional types in the same way that it applies to a type of thing wrapped by the optional. Suppose we have a reference type as an optional wrapping. A dog in this instance, right? You already know that you can assign a dog to it. Well, you can also assign a noisy dog or an optional wrapping of a noisy dog and an underlying wrapped that is object that is to maintain its integrity. We can do something like this to use an optional wrap. Optional wrapping, you can do something like this. We can say var, let's say var d, and we say dog, question mark, and we say d dog, d equals noisy dog, and d is optional. See? Over here gives us our optional wrapping. We can do something like this. We can wrap over noisy dog, so we say noisy dog done. That's how you wrap it. See? Just prints out noisy dog. So I hope this example helped you guys understand polymorphism. If you guys have any problems, questions, comments, concerns, just leave a comment below and I will help you guys. So thank you for watching, and I will see you guys on to the next video.